is nothing urgent here, just quiet facts about deep space, drifting slowly, one after another. You can close your eyes. You can let your mind rest. Everything here is calm and still. The universe is about 13.8 billion years old. That number is so large, it has almost no meaning to the human mind. And that is perfectly fine. It does not need to mean anything tonight. Welcome. This is a place for slow science, for facts that move at the pace of sleep. There is no rush here, and there never will be. Each fact will arrive gently, stay for a moment, and then quietly make way for the next one. Nothing here will surprise you loudly. Nothing here will ask anything of you. You are simply here resting, while the universe drifts by in soft pieces of information. Space is very large. It is also very quiet. And tonight, so are we. You can breathe slowly. You can let your thoughts settle. There is no destination. There is only this gentle movement through the facts of the cosmos, one calm idea at a time. The nearest star to Earth, other than the Sun, is called Proxima Centauri. It is about 4.24 light-years away. If you were traveling on the fastest spacecraft ever built by humans, it would take tens of thousands of years to reach it. That distance is simply there, existing quietly, whether anyone thinks about it or not. Light travels at about 299,792 kilometers per second. Even at that speed, light from the sun takes about 8 minutes to reach Earth. The sunlight you see on any given day left the sun 8 minutes before you noticed it. The sun makes up about 99.8% of all the mass in our solar system. Everything else, all the planets, moons, asteroids, and comets, fits into the remaining 0.2%. Saturn is the second largest planet in the solar system. It is also the least dense. If there were an ocean large enough to hold it, Saturn would float. Jupiter has a storm called the Great Red Spot. This storm has been observed for at least 350 years. It is a rotating system of clouds larger than the entire Earth. The surface of Venus is hotter than the surface of Mercury, even though Mercury is closer to the Sun. Venus has a thick atmosphere that traps heat. The average surface temperature on Venus is around 465 degrees Celsius. Mars has the largest volcano in the solar system. It is called Olympus Mons. It is about 21 kilometers high, which is nearly 3 times the height of Mount Everest. The Milky Way galaxy is estimated to contain between 100 billion and 400 billion stars. Our sun is just one of them, located in one of the galaxy's spiral arms, about 26,000 light-years from the center. It takes the solar system approximately 225 to 250 million years to complete one orbit around the center of the Milky Way. This is sometimes called a cosmic year or a galactic year. The center of the Milky Way contains a supermassive black hole called Sagittarius A. It has a mass about 4 million times greater than the Sun. It sits quietly at the center of the galaxy, as it has for billions of years. Black holes do not pull everything in. Objects need to be close enough to be affected by their gravity, just as with any other massive object. The Sun if it somehow became a black hole of the same mass, would not pull Earth in. Earth would simply continue orbiting it in the cold and the dark. A neutron star is the collapsed core of a massive star. These objects are extraordinarily dense. A teaspoon of neutron star material would weigh about 1 billion tons. Neutron stars are typically only about 20 kilometers across, yet they contain more mass than the Sun. Some neutron stars rotate very quickly. These are called pulsars. A pulsar can spin hundreds of times per second, emitting beams of radiation like a lighthouse turning in the dark. The Andromeda Galaxy is the nearest large galaxy to the Milky Way. It is about 2.537 million light years away. Andromeda and the Milky Way are moving toward each other and are expected to merge in about 4.5 billion years. The merger will be slow and gradual, taking hundreds of millions of years to complete. When two galaxies merge, most of the stars within them do not collide. The space between stars is so vast that they simply pass by each other, following new gravitational paths as the two galaxies slowly combine into one. The observable universe is estimated to be about 93 billion light years in diameter. This is the portion of the universe from which light has had time to reach us. The full universe may be much larger, or it may be infinite. No one knows for certain. There are estimated to be around 2 trillion galaxies in the observable universe. Each galaxy contains billions or hundreds of billions of stars. The total number of stars in the observable universe is estimated to be around 1 septillion, which is a 1 followed by 24 zeros. Space is not completely empty. Even in the vast voids between galaxies, there are occasional atoms, primarily hydrogen. On average, there is about 1 atom per cubic meter in deep intergalactic space. The cosmic microwave background radiation is a faint glow that fills the entire universe. It is the leftover light from the early universe, released about 380,000 years after the Big Bang. It has been traveling ever since, cooling and stretching as the universe expands. Today it exists as microwave radiation, invisible to human eyes, but detectable by sensitive instruments. The universe is still expanding. Every galaxy that is not gravitationally bound to our local group is moving away from us. The farther away a galaxy is, the faster it appears to be receding. Some galaxies are moving away from us faster than the speed of light, not because they are moving through space at that speed, but because the space between us and them is itself expanding. This expansion was discovered in the early 20th century. Astronomers noticed that the light from distant galaxies was shifted toward the red end of the spectrum. This redshift indicated that those galaxies were moving away. The more distant the galaxy, the greater the shift. Dark energy is the name given to the unknown force or property that is thought to be driving the accelerating expansion of the universe. It is estimated to make up about 68% of the total energy content of the universe. Very little is understood about it. Dark matter is another component of the universe that cannot be directly observed. It does not emit, absorb, or reflect light. Its existence is inferred from its gravitational effects on visible matter. Dark matter is estimated to make up about 27% of the universe. Ordinary matter, the kind that makes up stars, planets, and everything we can see and touch, accounts for only about 5%. So, the vast majority of the universe is made of things that cannot be directly seen or detected with current technology. The cosmos is mostly invisible to us, and that has been quietly true for the entire history of human observation. A light year is not a measure of time. It is a measure of distance. It is the distance that light travels in 1 year, which is approximately 9.46 trillion kilometers. When astronomers say a star is 400 light years away, they mean that its light takes 400 years to reach us. This also means that when we look at distant objects in space, we are looking back in time. The light arriving from a star 1,000 light years away left that star 1,000 years ago. We are seeing it as it was, not as it is now. Some of the stars visible in the night sky may no longer exist. They may have changed or died in the centuries since their light began its journey toward us. The Hubble Space Telescope was launched in 1990. It orbits Earth at an altitude of about 547 kilometers. Over its decades of operation, it has produced some of the deepest images of the universe ever captured. One famous observation: scientists pointed the telescope at a seemingly empty patch of sky for several days. The resulting image revealed thousands of galaxies, each containing billions of stars, all within a tiny fraction of the sky. The James Webb Space Telescope, launched in 2021, observes the universe in infrared light. This allows it to see through clouds of dust that block visible light, and to detect extremely distant objects whose light has been redshifted into the infrared range. It has captured images of galaxies that formed within a few 100 million years of the Big Bang. Stars are not all the same color. Their color depends on their surface temperature. Cooler stars appear red or orange. Stars with intermediate temperatures, like our sun, appear yellow or white. Hotter stars appear blue or blue-white. The color of a star is a quiet signal of its temperature and its stage of life. Stars spend most of their lives in a stable phase called the main sequence, during which they fuse hydrogen into helium in their cores. Our sun has been in this phase for about 4.6 billion years and is expected to remain in it for another 5 billion years or so. When a star like the sun eventually exhausts its hydrogen fuel, it will expand into a red giant. Its outer layers will swell outward, potentially engulfing the inner planets. Eventually, the outer layers will be shed into space, forming a structure called a planetary nebula. The remaining core will become a white dwarf, a small, dense object that slowly cools over billions of years. More massive stars have shorter lives and more dramatic endings. A star with several times the mass of the sun may live for only a few million years before exploding in a supernova. These explosions are among the most energetic events in the universe. For a brief time, a single supernova can outshine an entire galaxy. The elements produced in stars and scattered by supernovae are the building blocks of planets and living things. The carbon, oxygen, nitrogen, and iron in the human body were all created inside stars that existed before our sun was born. That material traveled through space and eventually became part of the cloud of gas and dust that formed our solar system. The solar system formed about 4.6 billion years ago from a collapsing cloud of gas and dust. As the cloud collapsed under gravity, most of the material gathered at the center and ignited as the sun. The remaining material formed a rotating disk from which the planets gradually accumulated. The four inner planets, Mercury, Venus, Earth, and Mars, are rocky. The four outer planets, Jupiter, Saturn, Uranus, and Neptune, are much larger and are composed mostly of gas and ice. Beyond Neptune lies a region called the Kuiper Belt, home to many small icy bodies, including Pluto. Pluto was reclassified as a dwarf planet in 2006. It orbits the Sun in an elliptical path that sometimes brings it closer to the Sun than Neptune. It has 5 known moons. Its largest moon, Charon, is so large relative to Pluto that the two are sometimes described as a double dwarf planet system. The asteroid belt lies between Mars and Jupiter. It contains millions of rocky and metallic objects, ranging in size from tiny fragments to the dwarf planet Ceres, which is about 940 kilometers in diameter. Despite what is sometimes depicted in popular images, the asteroid belt is mostly empty space. Spacecraft have passed through it without incident. Comets are icy bodies that originate in the outer regions of the solar system. When a comet travels close to the sun, heat causes its ices to sublimate, releasing gas and dust that form a glowing coma and often a long tail. Comet tails always point away from the sun, pushed by the solar wind. The solar wind is a continuous stream of charged particles flowing outward from the sun in all directions. It fills the entire solar system. At Earth, these particles are deflected by the planet's magnetic field. Near the poles, some particles are funneled into the upper atmosphere, creating the auroras, the shifting curtains of light, sometimes visible in the night sky at high latitudes. The Earth's magnetic field is generated by the movement of liquid iron in the planet's outer core. This field extends far into space, forming a region called the magnetosphere. The magnetosphere acts as a shield, deflecting much of the solar wind and protecting life on the surface from harmful radiation. The moon is Earth's only natural satellite. It is about 384,400 kilometers away on average. The moon is large enough relative to Earth that some scientists describe the Earth-Moon system as a double planet. The moon's gravitational pull is the primary cause of Earth's ocean tides. The moon is slowly moving away from Earth at a rate of about 3.8 centimeters per year. Over billions of years, this will gradually lengthen the distance between the two bodies. In the distant past, the moon was much closer, and tides would have been dramatically larger. The leading hypothesis for the moon's origin is called the giant impact hypothesis. According to this idea, early in Earth's history, a Mars-sized body collided with Earth. The debris from this collision eventually coalesced to form the moon. This would explain why the moon has a similar composition to Earth's outer layers. The moon has no atmosphere to speak of. Without an atmosphere, there is no weather, no wind, and no erosion from air or water. Footprints left on the moon's surface during the Apollo missions in the late 1960s and early 1970s are still there, largely undisturbed, and will remain so for millions of years. The surface of the moon is covered in a layer of fine, powdery material called regolith. It is formed by billions of years of meteorite impacts grinding the surface rock into dust. The regolith can be several meters deep in some areas. Mercury is the smallest planet in the solar system and the closest to the sun. Despite its proximity to the sun, it is not the hottest planet. Because it has almost no atmosphere, it cannot retain heat. The side facing the sun can reach temperatures of about 430 degrees Celsius, while the side facing away can drop to minus 180 degrees Celsius. Mercury also has the most elliptical orbit of any planet in the solar system. Its distance from the sun varies significantly throughout its year. A year on Mercury lasts only about 88 Earth days, but a day on Mercury, one full rotation, takes about 59 Earth days. Uranus rotates on its side. Its axial tilt is about 98 degrees, meaning it spins nearly horizontally relative to its orbit around the sun. This extreme tilt means that each pole experiences about 42 years of continuous sunlight, followed by 42 years of continuous darkness. Neptune is the farthest planet from the sun. It takes about 165 Earth years to complete one orbit. Neptune was first observed in 1846, and it did not complete its first full orbit since its discovery until 2011. It has the strongest winds of any planet in the solar system, with speeds reaching up to 2,100 kilometers per hour. Neptune has a large moon called Triton. Triton orbits Neptune in the opposite direction to the planet's rotation. This retrograde orbit suggests that Triton was not formed alongside Neptune, but was instead captured from elsewhere in the solar system, likely from the Kuiper belt. Triton is slowly spiraling inward and will eventually be torn apart by Neptune's gravity, possibly forming a ring system. The Voyager 1 spacecraft, launched in 1977, is the most distant human-made object in existence. It has traveled beyond the heliosphere, the region of space influenced by the sun's solar wind, and is now in interstellar space. As of recent years, it is more than 23 billion kilometers from the sun and continues to travel outward at about 17 kilometers per second. Voyager 1 and its twin, Voyager 2, both carry golden records. These are phonograph records containing sounds and images selected to represent life and culture on Earth. They were included in case the spacecraft were ever encountered by another intelligent civilization. The records contain greetings in 55 languages, music from many cultures, and sounds from nature. The concept of a habitable zone refers to the range of distances from a star where liquid water could exist on the surface of a planet. Earth sits comfortably within the Sun's habitable zone. Scientists searching for potentially habitable planets around other stars look for worlds in similar zones. Thousands of planets have been confirmed orbiting other stars. These are called exoplanets. They were first confirmed in the early 1990s. Since then, space telescopes and ground-based observatories have identified thousands more. Some of these exoplanets are rocky and orbit within the habitable zones of their stars. The method used most commonly to detect exoplanets is called the transit method. When a planet passes in front of its star from our point of view, it causes a small, regular dimming of the star's light. By measuring these dips, scientists can determine the size of the planet and how long its year is. Another method is called radial velocity. As a planet orbits a star, its gravity causes the star to wobble slightly. This wobble changes the wavelength of the star's light in a measurable way. By analyzing these changes, scientists can estimate the mass of the planet. Some exoplanets are nothing like anything in our solar system. Hot Jupiters are gas giants that orbit extremely close to their stars, completing an orbit in just a few days. Super-Earths are planets larger than Earth, but smaller than Neptune, a category that does not exist in our own solar system. There are also rogue planets, worlds that do not orbit any star. They travel through interstellar space alone. Some may have been ejected from their original solar systems by gravitational interactions. Others may have formed in isolation. The number of rogue planets in the galaxy is unknown, but may be very large. The Drake equation is a formula proposed in 1961 by astronomer Frank Drake. It estimates the number of civilizations in the Milky Way that might be capable of communicating with us. The equation includes factors such as the rate of star formation, the fraction of stars with planets, and the fraction of planets that develop intelligent life. The values of many of these factors are unknown, so estimates vary enormously. The Fermi paradox refers to the apparent contradiction between the high probability of extraterrestrial life existing somewhere in the vast universe and the complete absence of any evidence for it. Many possible explanations have been proposed. None has been confirmed. The silence continues quietly, as it always has.